In this video, we're going to be talking about compound inequalities, how to solve them, how to graph them, and write them in interval notation. So we're going to start off with, I'm going to go to these notes really fast. So you kind of know what compound inequalities are, which I'm sure you could have probably guessed because compound sentences are more than one sentence put together. Anyway, compound inequalities are two inequalities or more joined together with an, or, and or. So when we do this, or inequalities have a tendency to graph apart. What that means is when we graph or inequalities, when we graph them, one part of it is going to have an answer that goes one way, and the other part is going to have an answer that goes another way. So an example of this would be, let's say we solve, hide this for 1 second. Let's say we solve a problem. We get x is less than or equal to -2, or x is greater than 3. In that case, we would put a dot at -2, closed circle. Everything less than -2 would be an arrow to the left. X is greater than 3, that would be an open circle at 3. And because it's everything greater than 3, we would start there and draw an arrow to the right. So they kind of are graphed apart from each other. They're not together. And then when we write it in interval notation, we're kind of looking at it lowest to highest all the way across the graph. So we would start, it's going to keep going to the left. So it's going to keep going towards negative infinity. So that's where we would start, negative infinity. Anytime we put infinity or negative infinity, we're going to use a parenthesis. And then it goes and stops at -2. Anytime, just to recap interval notation, I know we talked about it in the last lesson, but anytime we have a point that's included, we're going to use a square bracket, so -2 square bracket. And then we can say or, the word. It starts then at 3, but it's not included, so that would be an open circle at 3. And then it keeps going to the right. So from 3 to positive infinity. So we're going to go through a few of these examples together, or in this video. What we're going to do is we're going to solve both sides. So they could be similar inequalities, they could be completely different, like number 1, they're completely different, and that's fine. So I would solve the first side just like normal, add 4 to both sides. And then in the second one, I would divide both by 2. Remember, if you multiply or divide by a negative, you have to change the direction of the sign. And then I can go ahead and graph these two. So x is less than -3 would be an open circle to the left. X is greater than or equal to 6 would be a closed circle to the right. And then when I write that interval notation, it's going to start at negative infinity, stop at -3, but it's not included, so that would be a parenthesis. Or it would start at positive 6, it's included, so square bracket, and then continue on to positive infinity, so parenthesis. For number 2, and we're not going to do all of these, we're just going to jump around to a few. Number 2, same thing, solve both sides, or both inequalities. So in this case, I'm dividing by a negative, so I have x is greater than or equal to positive 3. And I really should be bringing down this board just so I remember. And then I can subtract 5. So x is less than 1. So here, I'm going to start at 3. I have a closed circle, and I'm going to graph it to the right. And then x is less than 1 is going to be an open circle at 1, but I'm graphing it to the left. So notice that in the first example we had an example that went to the left and to the right. The first inequality went to the left, the second went to the right. But then in our second example, the first inequality went to the right and the second inequality went to the left. That could happen sometimes, so don't assume it's going to automatically go whichever direction, especially if you have to multiply or divide by a negative number. Let's jump down to not a harder one, but there's more steps. So for this one, let's do number 5. On the left side, or the first inequality, I would need to do one of two things. You can either distribute, so I'll show both ways, negative 6x minus 3 less than negative 15, and then solve for x. I'm dividing by a negative here, so my sign is going to change places to positive 2. Or what I could have done from the beginning, so let me rewrite this really fast. Because negative 3 goes into negative 15, I could have divided both sides by a negative 3. So I don't need this parenthesis anymore. Except because I'm dividing by a negative, my sign changes, just like it did in the pink example. So that kind of makes sense. It would need to change directions. And then I could solve for x just like normal. You would still get the same thing either way, that x is greater than 2, so that would be an open circle going to the right. And then I could solve for my other inequality. And here you could also do this one of two ways, so I'm going to show you both. The way you were probably thinking is to subtract 1 from both sides, and then divide both sides by a negative 1, which would change the direction of the sign. The other way, let me rewrite this really fast, would be if I moved my x to the other side, so add x, and then subtract 5. That way I don't have to worry about the negative, dividing by the negative and changing the sign. And now I have negative 4 is greater than or equal to x. Nope, that messed everything up. Disregard that part. Forget that I said that. So here I could graph, oh, that's why. I'm sorry. Don't disregard what I said. Let's go back. I was going to end up with a negative, and I was like, but I didn't end up with a negative. It's because I forgot my negative. Okay, anyway, going back to the second example, negative 4 is greater than or equal to x. I'm going to switch this so that I don't confuse the order. This would be the same thing as x is less than or equal to negative 4, which is what we had originally. So I would make a closed circle at negative 4 and draw my arrow to the left. Okay. So those were all or inequalities. Now we're going to talk about and inequalities. And inequalities have a tendency to graph together. So or graphs apart and graphs together. So an example of this is given here. We have x is like we solve two inequalities, we have x is greater than or equal to -6 and x is less than or equal to -1, what happens is I'm going to draw a couple things. So I'm going to draw this one in purple. So x is greater than or equal to -6. I would have a closed circle with an arrow. And then I'm going to draw this one in this magenta color. X is less than or equal to 1. So at 1, I'm going to draw a close, have a closed point, draw my arrow to the left. Because we're looking for an and, we are looking for where do these two overlap, and that's going to be from this point to this point right here. And that's it. So really when we graph this, go back. We're going to get rid of the arrows, kind of fix it, so that it starts at -6 and it stops at 1, and it's just this line right here. Because it's an and inequality, it has to be where they both are, or can be either or, but and has to be both. They both have to fall in the same general area. So the interval notation for this would be from -6, it's a closed circle, so that would be a square bracket, to +1. This would not go to positive and negative infinity, even though that's what it says. And then in this reasoning, it says because the solutions to an and inequality fall between two endpoints, they are frequently written in a more condensed form. So instead of x is greater than or equal to -6 and x is less than or equal to 1, which is what the problem said, we would change that so it's kind of in, so we're like going back to set builder notation. -6 is less than or equal to x, which is less than or equal to 1. So now that we've talked about how you would graph those types of equations, let's talk about how we would solve them. So for number 6, we would take what's in the middle, you're going to solve it, but when you solve it, you're going to do it to both sides. So I'm going to subtract 4, but when I subtract 4 to the other side, I'm going to subtract 4 here and here. So that's going to give me -2 is less than or equal to x, which is just less than, 5. What's nice about this is that because it's already in that format, we don't have to draw the arrows and erase the arrows. We can just draw from this to this point. So that would be from -2 with a closed circle to +5 with an open circle, and I would connect those two. Let's do a couple more. And let's do the interval notation first. So from -2 to 5 would be a square bracket, -2, comma, 5 with a parenthesis. For number 7, we would start solving this like a normal inequality at 13, but I'm going to do it to both sides of the inequality. So this would give me -14 is less than 7x, which is less than 21. Then I'm going to divide both sides by 7. So this is where it gets a little tricky, not in this problem per se, but later when you get negative coefficients, your signs are going to change direction. So be mindful of those. So this would become -2 is less than x, which is less than 3. Always make sure that you're keeping the right less than or greater than or equal to signs. So this would be an open circle at -2 and an open circle at 3, and I would connect those two. So my interval notation would be parenthesis -2, comma 3 parentheses. We're going to do just a couple more. We're going to do 9 and then we'll do 10. For number 9, we would need to subtract on both sides. So this would give us -2 is less than 2/3 x is less than or equal to 4. And then to get rid of 2/3, we're going to multiply each piece by 3/2. So this would become -6/2, which is -3, less than x less than or equal to 12/2, which is 6. So I would start at -3 with an open circle, go to +6 with a closed circle, and connect them. So this would be -3 to +6 with a square bracket. In the last example, you could do this a couple different ways. So I'm going to show you both. One is going to distribute, and one is going to be to get rid of the two altogether. So let's distribute first. So then we could, this is supposed to be -12. We could add 12 to both sides. So this would give us 10 is less than 2x, which is less than or equal to 16. And then I could divide everything by 2. So 5 is less than x, which is less than or equal to 8. Before I grab this and do interval notation, let me do the other way. So I could divide each piece by 2 since they're all divisible by 2. So this would give me -1 is less than x minus 6, which is less than or equal to 2. And then I could add 6 to both sides, or to all sides, I should say. And I would get 5 is less than x, which is less than or equal to 8. So it does not matter how you do that. And then we have an open circle at 5 and a closed circle at 8. And we could draw that line. So this would be parenthesis 5 and then comma 8 with a square bracket. Now you'll have a chance to go and practice some more. Let me know if you have any questions.